Welcome back, everybody. We're going to start section R.2 today on real numbers and their properties. So let's start with what each of these number sets are. We have natural numbers, which are your counting numbers, 1, 2, 3, 4, 5. The addition to the number set for whole numbers is adding 0. 0 has a hole in it. That's kind of how I try to remember that. Integers now uses the whole numbers, but adds the negative parts of them. Rational numbers has all of these top three, plus fractions and decimals that repeat or are finite. Irrational numbers are kind of off on their own. These are going to be non-perfect square roots. Pi, non-repeating, never-ending decimals. And then real numbers are all of these. These are all real numbers and anything that can be placed somewhere on a number line. Example 1, list the numbers that belong in each set. Well, I'm going to take a look at what we have here, and I notice that the square root of 9 is a perfect square, and that is a 3. So that's going to change maybe where we might place that. Natural numbers then. Remember, natural numbers are counting numbers. So we would have 1, 6, and the square root of 9, because the square root of 9 is 3, which is a natural number. Whole numbers will have what we have in natural numbers and include the 0. Integers. Remember, integers, we take the whole numbers and then we take a look at the negatives. So we have -8 and -6. I noticed that -12 is actually -3. So we can include that here. 0, 1, 6, and the square root of 9. Rational numbers are going to be pretty much everything on here with the exception of the square root of 2 and the square root of 5, because those are non-perfect square roots. So we can list -8, -6, -12, -3, 0, 3/8, 1/2, 1, 6, and the square root of 9. Irrational numbers, remember those are the non-repeating, non-ending decimals or the imperfect square roots, meaning square roots that when we try to find them, we get a decimal, and that's going to be the square root of 2 and the square root of 5. Real numbers, all elements of A. So all elements of set A would be real numbers, or you can list that whole list of numbers. Exponents. An exponential expression is 2 to the third power. The base is 2. The exponent is 3. 2 to the third power means 2 times 2 times 2. So for these examples, I have 4 to the third means 4 times 4 times 4. 4 times 4 times 4 is 64. These two are going to be very important. We want to make sure we pay attention to this. If you're using a calculator, number 2 is in parentheses. You want to make sure that you're using the parentheses when you use the calculator as well. -6 squared means -6 times -6. -6 times -6 is positive 36. We include the negative with it because it's grouped with the 6 inside the parentheses. -6 squared means -1 times 6 squared. So square 6 and then multiply it by -1. So that's -36. And actually, I made a typo. That should be on the outside. I apologize for that. Number 4. 4 times 3 squared is 4 times 3 times 3. 3 times 3 is 9. Times 4 is 36. Versus 4 times 3 squared with the parentheses. Remember, order of operations says first we have to take care of parentheses, then the exponent. So 4 times 3 is 12, and then 12 squared is 12 times 12, or 144. Order of operations is more than just please excuse my dear Aunt Sally anymore. We're going to work separately above and below each fraction bar. Then we're going to take care of parentheses, brackets, any of those grouping symbols. Start with the innermost and work your way out. Powers and roots, or exponents and roots, work your way from left to right. Multiply and divide, work your way from left to right. So you don't necessarily do multiplication first through it, then division. It's whichever of those two operations comes first from left to right. Same thing with adding and subtracting. Let's try a couple. I'm going to start with the exponents. Remember, we're still looking at basically PEMDAS. So 2 to the third power, 2 cubed, is 8. So 6 divided by 3 plus 8 times 5. Then we take care of multiplication and division. So I have a division first. That's 2. Bring down the addition sign. And then the multiplication of 8 times 5 is 40. 2 plus 40 is 42. That would be our final answer. Number 2, grouping symbols first. So inside the parentheses, we have 8 plus 6. 8 plus 6 is 14. Then working left to right with multiplying and dividing, we start with 14 divided by 7, which is 2. Then the multiplying of 2 times 3, which is 6. And 6 minus 6 is 0. Number 3, remember we said you have to work the top and the bottom of the fractions separately first. It's kind of like there's invisible grouping symbols around them. So in the numerator, or the top of the fraction, we would start with 3 squared. 3 squared is 9. 4 plus 9 is 13. On the bottom, we have to take care of the multiplication first. 5 times 3 is 15. 6 minus 15 is -9. So -13/9 is going to be our final answer. Number 4, again, we have kind of invisible grouping symbols on the top and the bottom. We start on the inside of -3 cubed. It's -3 to the third power, or -3 times -3 times -3. Be super very careful because there's a negative here. You can't say, oh, there's a double negative. Nope, it doesn't work that way. You have to start with this and keep that very first negative on the outside. So -3 to the third power is -27. I'm bringing everything from there. Now I can say, oh, look, I've got two negatives right next to each other. So that makes that positive 27. Positive 27 plus -5 is positive 22. On the bottom, I have to take care of the multiplication first. So 2 times -8 is -16, and 5 times 3 is 15. There's a subtraction here, so it's going to come back. Now I can do -16 minus 15 more, which is -31. That makes our final answer -22 over 31. Last example we're going to talk about today is evaluating. So evaluating means you're going to plug in a value, and they're telling us what we're going to plug in for each letter. So we start with example 1, -4. X, we're plugging in a -2. Minus 7 times y, which is 5, plus 4 times z, which is -3. Start with the -2 squared. -2 times -2 is +4. I'm still working with multiplication, so I'm going to do these 3 multiplication problems next. -4 times 4 is -16. 7 times 5 is 35. And then 4 times -3 is -12. Last but not least, then we take care of the adding. -16 minus 35 more plus -12 gives us an overall answer of -63. Number 2. 2 times x is -2 minus 5 squared plus 4 times y, which we're replacing with 5, and then -3 plus 4 on the bottom. Erase so we have some room for work. Starting on the top or in the numerator with the parentheses, I'm going to do the -2 minus 5. That gives us -7 squared. -7 squared, because the -7 is inside the parentheses, then that's going to be -7 times -7, which is +49. And we bring over the plus 4 times 5. Take care of the multiplication on the top. 2 times 49 plus 4 times 5 gives us 98 plus 20. I'm going to go ahead and take care of the -3 plus 4 on the bottom, which is 1. 98 plus 20 is 118 over 1, and 118 divided by 1 is 118. This is where we're going to stop for today. We'll pick this back up with the next video. Thanks for joining. Have a great night.